Okay. So I hope you guys had a good time during the holiday. So this is lecture 3. It's about a package called NumPy or Numpy. Okay, it depends on your pronunciation, and array. Okay, so before we go into the details for this lecture, I would like to point out how we use print function, because some of you have asked me. So if you use the print function like this, it would be an empty line, and it would automatically add a new line character. So this /n means it's a new line character. So it will add /n to the end of the print function automatically. So even if you print nothing here, it would still skip to the next line. Okay. And the second one, why are there 2 new lines? Because you have put a new line character here, and it would automatically add another new line character here. Okay. And for the third one, because you have put a comma here, you are printing 2 variables. So it means that you can print different data type. Okay, you can print string, you can print integer and float within the same print function. Okay, separate them with comma. Or you can change the separator. So automatically or by default, it would be a space, right, between 10 and ABC here, right, 2 variable. It would be a space, but you can change that to other characters. For example, here I put 3 stars in here. Okay, so case 4, the 3 stars in here. And for case 5, what is this? You are printing 3 variables. The first one is var1, which is 10. Second one is still a variable. It's a string variable. Okay, it's a string variable with a new line character. So it skipped to the new line, and you still have a separator. So there is a space here, right? It's the space separator. And then variable 2. What is variable 2? Is a string, again, ABC. Okay. And what would be the last one? If you put a plus operator here instead of a comma, what happened? You're adding the 2 strings here, because var2 is a string, right? You have to change var1 into a string also. So comma and the plus, the addition operator here, they're not the same. Okay. If you put a comma here, it would be printing different variables. If you put a plus here, you are adding, for example, if you are putting 2 integer variables here, they will be added. And then you're printing just 1 variable. Remember that. Okay. So when you are printing stuff, it would be the print function actually is the very first function that you have learned, and it's very important when you do debugging, right? When you do your debugging process for your homework for any coding, everybody has to do that. Okay, so today's lecture is about packages and NumPy array. So another point to note about the runtime in Colab. Okay, so it turns out that you can look at the values of your different variables just by tapping this X operator in X button in here. Okay. So if, let's say if you have a program here, the Python program on the right, it's actually a part of the cheat sheet that I've already released on the Blackboard. It's for your final. Okay. So let's say you have different variables here, and you have already run this by 1 time, and your computer already saved the different variables in there. For example, the A4 here, Avogadro's number, 6.02 times 10 to the power of 23. Okay. If you move your mouse to this variable in the variable list in here on the left, so you tap this, right? And then you will see the value of a variable. It's very useful here. So now you know what would be the value behind each of the variables in here. Okay. Okay, just move your mouse over. For example, this list 1, you know that the value for this list is 1, 2, and 3, right? And you have extended that by using this method. We have learned about this in lecture 2, right? List 1 dot extend, and your list 2 will be added to list 1, right? So now it becomes 1, 2, 3, 4, 5. Okay, I have a U reply quiz for you. So what should be the value of list 1 if we run the second cell again? Just the second cell again. Okay, would it be 1, 2, 3 or 1, 2, 3, 4, 5? Just like what you see in here. I've run this just one time, right? Okay, and or 1, 2, 3, 4, 5, 4, 5. Okay. This is counted as your participation. Please do it. Okay, who needs more time here? What about the 3 people in here? 33 out of 36. Okay. Anyone needs more time? I'll give you 5 more seconds. Okay. Yes, the answer is C. Okay. Oh. Okay. Let me go back. Okay. Why the answer is C? Because you will have to execute this again, and then you will extend list 1 again. List 1 has already become this 1, 2, 3, 4, 5 on the screen, right? If so, it's already showing you this. So if you extend that again, it will be C, which means that this will bring back my message is that sometimes you will have to restart the runtime to clear everything in the memory. Okay. Before you submit your homework, I suggest you to do it once, right? Restart your runtime and run everything, run all, or you just tap this restart and run all to see if your program is okay or not, right? Because if you're working on your homework, sometimes you just run some of the cells, right? and that is not okay. Sometimes you will mix up some of the process that you need, okay? So restart one time. Or use this restart and run all, okay? Run all means running all the cells in your Google Colab, right? If you restart the runtime, it would be clear. Okay, so now we go back to the main lecture material, okay? So this time we will talk about libraries or package or modules. Actually, they're not the same, but at this stage, you just need to know that they are some functions or some methods provided by other people. They are pre-written codes. You want to include them in your codes because you don't want to write them again, okay? And they could be used for different purposes. For example, here, you have imported a library or module called math, M-A-T-H, math here. And you want to print one of the function inside this math library, just like what you do with your calculator. Sometimes you bring out the pi right inside because you don't want to type everything in here. Even if you are very smart and you can remember this to a very far decimal place, right? But sometimes it's not precise, right? You want to have a more precise pi value, then you bring out the library, you import the library. So how do we import a library? So this is an import statement. Import is obviously a reserved word, so it cannot be used as a variable name. Don't do that, okay? And then the name of your module is math. And now you have imported the module or the library, then you can use anything inside. So how do we use the thing, use the functions or use the variables inside? You use the module name and then dot something. Okay, here is math.py. Okay. Some of the library you will have to install them, but for some of them it's there already, right? When you have the Python. I think math is already included in the Google Colab, the console inside. Okay, so sometimes the module name is just too long. We don't want to just type math, for example, here every single time. For example, here, import math, and you want to use the sign function inside this library, right? Math.sign. Of course, you have to put something here, right? It's a function, right? You're calculating this sine pi over 2. I guess you have all learned about this, right? 有冇人唔知咩叫 sign function 嘅? Okay, right here, we are calculating this one. Okay, so pi over 2. Now we think that, okay, this math is just too long. We don't want to type this every single time. So we give an alias to this math library, import math as MT, and you will have to just use MT as the name for this library. Okay, so import math or import math as MT, and then you will use MT for the rest of your program. Okay, so pretty easy. What's the difference between these two? Okay, so how do we use a package? So to generalize everything here, we have used the module name right here. What is the module name? It's math, right? Or MT. Okay, dot. And then what is this one? The next one after the dot is the function. Pi is also a function, but there is no argument for this pi, right? Math.py. There's no argument for this function. But for the sign function, there's an argument. What is the argument for this sign function? The argument is in the bracket. Okay, the argument is pi over 2. Okay, so you have to know the names of different things. If you want to Google everything, you need to know the name. So this is a module, sign is a function, and then whatever inside is the arguments. It could be one argument. Here is just one argument, right? It could be two, right? If you put a comma here and then you're inputting two variables into this function, this sign function. Okay, module name, function name, arguments. Okay, sometimes we import the function directly. So how do we do that? From this math library, we import just two functions, which is sine and pi here. So if you do it like this, this is another import statement, but a special one. If you import the library like this, you don't need to type the module name here anymore when you use the functions. It will be looking like it's an intrinsic function already included in your original Python, but it's imported. Okay. So note that the function pi does not require any arguments. It's a constant, right? You don't need to import anything. Okay, so now you can do it like this, but usually we don't do it like this. We import everything. Sometimes you want to make your program faster, so you just input two functions. This is about efficiency only. Okay, so the first one, this is a summary. The first one is the simple way, right? The second one is that we have used the alias empty, change the math to empty here, right? The third one is that we just import some of the functions, sine and pi here from the package. So it's pretty easy. Okay, so that's not the library we want to talk about in this lecture. In this lecture, we want to talk about this NumPy library, which is very, very important in all the scientific and engineering world. Okay, NumPy stands for numerical Python, which means that when we calculate anything, we'll need this NumPy library. Okay, it's open source, which means that it's freely available, and used in all the fields in science and engineering, and standard for working with numerical data. And also it's very convenient if we want to work with multi-dimensional data. Here we just have 1D, right? The Earth, of course, is 3D, right? If you include time, that would be 4D, right? 4-dimensional variable. If we want to deal with that in a faster way, we will need to use Python. Okay. So here we import this NumPy as NP. It's too long, right? 1, 2, 3, 4, 5 characters. We don't want to type this every time. So we use the alias NP here, which stands for NumPy. Here we have a list. You have already learned about this, right? Last lesson. A list is an ensemble of different values. Okay, here we have 5 values, 1, 2, 3, 4, 5, and they are separated by comma. Remember that. Okay, and then we print that. You can see that it's a list. We can turn this list into an array by using this NumPy array function. This is a function, turning any list into an array. So you will see that, okay, so what's the difference, right? It's exactly the same, except that when you print the array, you don't see the comma here anymore. It's just space, right? Spaces between. In this lesson, we will tell you the difference, okay? So first of all, the data type. For an array, it's only one data type. For a list, you can, this is on the top, the example is from the last slide, okay? On the bottom, we have changed 2 and 3 into a string, and it still works. You can see that, right? You can include an integer, you can include a string, you can include any data type in just one list, right? And if you try to turn this list into an array, what happened? Your array function will turn everything to string, because for the NumPy array, it has to just contain one data type, which is string here. Okay. If we compare list and array, there is one thing which is very convenient for us is that if we want to do element-wise operations, Element-wise meaning we work on all the element, right? The element for this one is 1, 2, 3, 4, 5. 5 elements in here, right? 5 variables or 5 values, not 5 variables, just one variable, 5 values. Okay, if we want to add 1 to every single element here, just by 1 bigger, okay, we want to increase the value by 1, and we try to do this plus 1, what would happen? It will give you an error message because list doesn't allow you to do that. If you add 1, it will tell you that you can only concatenate list. Oh, we will explain this term in the next slide. Okay, don't worry, just remember that we can do this. Okay, and for the NumPy array, we can exactly do this what we had just said, right? Plus 1, 2, 3, 4, 5, 6 in here. So it's just simple for NumPy array because it's the same data type, right? It can ensure that you are doing the same operation to all the elements. If you're having different data type and you add 1, and that's not okay, right? So list is the different things that a list can do is very limited comparing to an array. Okay, this is one of the things, element-wise operations. Okay, so what does it mean by concatenate for a list? Okay, it means this. If you want to add something, it's just like a string, right? If you want to add something in, if you want to add another element, you can use plus. Plus is for you to add another element for a list. Okay, we don't deal with lists a lot actually. We use NumPy array most of the times because it's more it's neat actually. It's more convenient. I think I have never done this one, just add one element to a list because we don't use lists a lot. Okay, so if we compare list and array, okay, sometimes you have 3 values in here, right? -1, -2, -3, and you want to absolute everything, change that into 1, 2, and 3, and you try to use this absolute function. We have learned about this function right last time, and it will tell you that okay, it's not okay. Bad operand means the argument inside, right? This one is not okay for your absolute function because it's a list, and it's not okay because again, a list can contain a string, can contain a float number and an integer number, and if you put a list inside, and your absolute function will not operate that. Okay, but for your NumPy array, you can exactly do this, but this absolute function is not the intrinsic function. It's the absolute function coming from the NumPy array because NumPy library. Okay, because you're working on NumPy library, you have to use the NumPy absolute function from the NumPy array. Okay, if you put this array 1 into the function, it will give you exactly what we had just said, right? 1, 2, and 3. Absolute the 3 negative values in here. Okay, so here this is a little bit advanced for you. I have already talked about the concept of memory, right? Inside, it's actually in your RAM. If you don't know what RAM is, it's okay. If you turn off the computer, everything in your RAM is gone. Okay, I think you already have this concept, right? When you work on with your Word and then it suddenly shut down and you have lost everything because it's in your RAM. It's in your fast memory. Okay, so for a list, how does the computer remember your list? How is it put in the storage? Actually, for your computer, it only remembers the addresses. For example, here, 1, 2, 3, 4, 5, you have 5 values in here, and they have different data types. If they have different data types, you will need different sizes in here, right? For one or for the sun, for the moon, 4 and 5, they will have different sizes, which means that your computer will have no way to remember them sequentially in order. They cannot remember them in order. What your computer do is that it will put your values in random locations in your memory, and it just remember the addresses here. The addresses, they have the same size. 1, 2, 3, 4, they have the same size. And then they can use this address to look for your values in the memory. Okay, so they're stored randomly in the memory. Each block have different sizes due to different data types. And a list is to save the addresses, the gray values in here, okay? And because the addresses have the same size, it would be more convenient. Okay, for the array, it's not the same because they are with the same data type, whether it's a float or integer, they use the same size, right? Each of the block, they will have the same size, right? So here is actually not very accurate because moon doesn't use the same block of memory as the sun or S4. Okay, so I shouldn't have put these values in here. Never mind, I'm just showing you the concept. Okay, so for the array, for the NumPy array, it's more convenient. So your computer, if you're talking about ARR1 in here, it just has to remember the first address because you can calculate where they are, right? If you know, okay, it's 100, the 100th value, then you can just calculate, your computer can calculate where they are and then just point out the value immediately. It doesn't have to do this sequential thing in here, right? Which means that it would allow faster operations. Okay, on the bottom here, array. Okay. So which means that your array 1 here is a pointer, actually. It's a pointer pointing to the address. It's not, actually, it doesn't mean anything. It's not remembering these for you. It's just remembering where they are for you. Just the first address. Okay. If you don't understand, it's okay, but it will be better if you know the operations behind. Okay, so here, NumPy arrays, how a list, of course, list is too slow. I've just introduced the concept of the differences between list and NumPy arrays. It would be more efficient to manipulate large amount of numbers. So if you have large amount of, for example, here 2D numbers, right, in space, actually it's 3D, right? We have 3D space. It's not 2D space, but if you look at the map, it's giving you a 2D sense, okay? If you want to pinpoint something on the map, what do? You don't do a sequential search, right? You don't do it row by row. You just point out the point, right? If you have a NumPy array, then you can do it in a very fast manner because you know the latitude and longitude, you know the X and Y, right? It would be very, very fast. Okay, compatible with other packages. And the example here is showing you the spatial distribution of surface temperature at different times. So you have, for example, if you have some surface temperatures for all the points on the world, and then you can use the 2D NumPy array. And if it's in space, then it would be 3D, right? X, Y, and T. Okay, so again, we started with a list 2, 3, 5, 7, and then turn that into a NumPy array by using this np.array function. Okay, so again, remember that they are not the same. The one with the comma is a list. The one with the spaces, they are the NumPy array. Okay, or you can just type everything and put that in your array function. So this is still a list, right? It's turning a list into an array. They're exactly the same, but I'm showing you that we are putting a list in here. So you have to use comma, even though when you print it out, it will be with spaces in here. Okay, here is 1D only. So you are storing 1, 2, 3, 4 values. Okay. How do we create arrays besides typing everything in here? Sometimes we initiate empty variables. For example, here there are 3 variables. Initiate a variable with all zeros in here, 3 zeros. It's automatically giving you a float number array, right? There is a decimal point in here. And for the next one, all ones. Sometimes you need to multiply your empty array with something else. You don't want to multiply that by 0, right? You want to multiply that by 1 because it would be giving you the initial value, right? So they have different purposes, zeros and ones. And we don't recommend using this empty function because you can see that it's random variables. It's giving you whatever inside your memory, which is just something that is random, right? So here we are using the alias numpy np. We don't want to type everything, right? We don't want to type numpy. We want to type np. Dot zeros is the function name. And then 3 is the argument. It just need 1 argument. Okay. Sometimes it can have different arguments. So if you want to, if you want to search, if you want to expand, for example, I go back to the number print function. Okay, if you want to do something not in the ordinary way, right? For example, this function, you want to Google that, okay? Google print, and then you Google argument. You'll see that there are different options. For example, here, this SEP meaning separator. Okay, you can definitely Google that. So because this course will not, I don't think any course can introduce all the functions or all the options that it's inside every single function. So we cannot do that. So I have to teach you how to do that on your own. Okay, if you want to expand the usage of a certain function, so how do you do that? You Google print and then you Google argument or options. Then it will give you something like this. For example, this separator, you can change some of the options that is default in the function. Okay. Let me go back. Okay, so that's why I'm introducing some proper names for you on the right-hand side. If you want to Google anything, it will become handy. Okay, so next, this is very, very useful. Creation of numpy arrays with a range in here. A range is a function, right? It's giving you a range, right? As it's as advertised in here, the name. Okay, import numpy as np again, and then we use the function a range in here. So it's just like the slice notation that we have learned last time. 2 to 7, actually 7 is not included again. It's just like the slice notation. And 0.5, the step is 0.5. Okay, so 0 at 0.5 and then add so on and so forth until 7, but 7 is not included. Okay. So here, how many arguments are there? 2, 7, 0.5. 3 arguments. Okay, 2, 7, 0.5. Maybe there are some more. You have to, if you want to expand the usage, you have to Google that. Maybe it would just accept 3 arguments. Okay. So a range is array range. And then it's pretty simple. I think you understand this if you have learned about slice notation. Okay, so let's say if you want to substitute different variables in these 3 arguments into these 3 arguments, 2, 7, 0.5. You use a variable so that you can change them, right? You can change them later. You don't want to hard code. So the first one is what we call hard coding. We don't want to do that because next time when you want to change the variable, when you sometimes maybe you have calculated that from a function, then you don't need to change it, right? It will calculate that for you. So you put that into a variable. And this is what I do personally, because it's very confusing in Python. So if we want to do the range 2 to 7, I would do this 7 plus the interval to avoid not having 7 in your range. It would be easier for you to look at when you look at the different values in here. So you would look at, okay, 2 to 7, you know that you are doing the range between 2 and 7 included. Okay, this is a trick that I've been using. You don't have to follow this actually. You just need to know that this second argument is not included. 7 is not included in this range function. Okay. Okay, here the step. Here, this is another function called linear space, LIN space. So what is doing is that it's doing linearly spaced values from 2 to 7. And between them, not between them, actually 2 and 7, they are included. There are 11 values. So if you count this, there are 11 numbers in here and 7 is included. So it's not the same comparing to a range. 2 and 7 are included, and in between them, 9 numbers, right? 2 and 7 already, 2 numbers. Okay. So in here, we don't know the step. Your computer will calculate that for you. We don't need to know the steps, right? Plus n. And it's just happened that it looks pretty, right? The step is 0.5. What if we change 11 to 12? It will still give you evenly spaced numbers, but it will not be pretty. Okay, it will not guarantee to give you a pretty step value. Okay, so because we don't need to know, right? We don't need to know. You just need to know the first one and the last one and number the number of values that you need. Okay, why do we do this? Sometimes we need to generate a function, for example, right? And we want to plot that on a graph. So that's why we need to generate array. So this is a summary comparison between the two examples that we have cited here. So 2 to 7, 11 values, 2 to 7, 12 values. So you don't need to know the steps again. Okay, here, this is a comparison between a range and linear space. In a range, you need to know the step, right? And 7 is not included. And for linear space, you don't need to know the steps, and the n is included. But you need to know what? You need to know how many numbers you need when you have the output, right? The output is a. So your function output is put into this a value, and then you're printing this. A is an array in here. Okay. It's very important because when we do this, sometimes we are skipping to a different locations, right? For example, here we are doing this 1, 2, this location. We want to look for example, the longitude and latitude. And if you have this a range and linear space, it would be easier for you to look for the longitude and latitude inside your data. When you do loops later, I think next week. Okay. Okay, so NumPy creation. So another way to create a NumPy we can create new ones and zeros array using the size of an existing array. So if you want to create another array with the same size exactly as this array one, ARR1, 4 values, right? You put it inside the argument, then you will generate 2 NumPy arrays with the same sizes, with the same size, all zeros and all ones, okay? Okay, so this is very important. Please do not use equal operator, equal sign to copy arrays. So for the first one on top, I'll explain to you why. Okay, the first one on top, you had generate another NumPy array here, right? 2, 3, 5, 7. And then you try to copy that to another variable B in here. Okay, you think that, okay, you have 2 variables already. But actually, as I have just said, your computer is remembering the address only. So A and B are pointing to the same address. And that's not okay, right? When you change the value of A, okay, you are changing index 1, which is index 1, the second one, right? This is 2 is index 0, 3 is index 1. You're changing this to 0. You're changing one of them. You're just changing A, but you are also changing B. When you print them, you'll see that you're changing both of them because they are pointing to the same address. They're not 2 different variables, right? If you don't get this, don't worry. Just don't use the equal sign on your NumPy array. When you debug them, when you debug your code, and when you print them, you'll find that, okay, I've just changed one of the arrays. Why are they changing also together? That's not okay, right? Okay, and for the second example, is just exactly as the same one, but we are changing another array, changing B only. Okay, and they are giving you the same result. It's not okay. So it turns out that we have to okay, here the second one would be okay. You're still using the equal sign, but you're assigning new values to your variable B. Now your variable B becomes a whole new variable. It's not even a NumPy array, it's a string, right? Then it's okay because you are changing the value to new values. When you do this reassignment, then it will be pointing to a different variable in the memory. Okay. So it turns out that the proper way to do this is to use the NumPy copy function. Copy the array value to B. And then when you change the value of A, that would be okay, right? You're just changing the value of A, 2057 here. And you're not changing the values for B because they are pointing to different locations. Okay. So the proper term in the computer science world is pass by reference and pass by value. Okay. Pass by reference meaning you are passing the address only. Okay. Pass by value, you are passing the value only. So if you use copy here, you're passing the value and then you are generating a new variable. Okay, the IDs, the addresses, they are the same. They are different locations for the bottom case in here. For the upper case, they are the same location. They're the same address, right? Address here. Okay. So another, this is a GIF. Sorry, this is an animation. You have to tap into this to look at so pass by reference and pass by value. They're giving you different results. Okay. So there are 2 cases in here. The first case is giving you the same location. Second case giving you different locations. So which one is correct here? So A, B, C, and D. Case 1, pass by reference or pass by value. Case 2, pass by reference or pass by value. Okay, please do the question. Okay. Okay. Most of you have answered 1. The first one is, yes, pass by reference, and the second one pass by value. You're just passing the values. You're creating 2 variables in here, 2 different locations. So A, yes. So if you, maybe we can tap into this too. Okay, so this is the GIF that I have put in the slide. So if you are passing by reference, you're passing the address. So when you change the value for this cup is meaning that it's containing some value, right? If you're changing the value for a certain variable, both of them are changing together, right? If you're passing just the value, so the value here is 0, right? 0, no tea or no coffee in your cup. So you're just passing, and then you can change the variable in here, and then without changing the original variable. Okay. Okay, so this is fill in the blanks. I think it would be pretty easy for you. Just choose one of the options given to you. Answer the questions for the range. Range is just for integer. Remember that last time we have learned about this. NumPy, a range function, NumPy linear space function. Okay.